continuity corrections. These are needed when you go from a discrete distribution, you approximate to a continuous distribution. So basically, binomial to normal and Poisson to normal, that's where this would be needed. And there are a lot of really boring rules that some people like to remember in order to figure out the correction. I would write them, except I don't remember them, so that creates a bit of a problem. But I just use this Jugaad type logic to help me remember, and I think that's just the easier way to go about rather than remember 5, 6 different rules and ways to do so. So let's talk about when x and the idea here is continuity correction will either add or subtract 0.5 to your x value. And yeah, there's an entire logic behind that, but we won't be going into that, not in this video at the very least, not so close to the exam. Uh, so okay, so you either have to add or subtract 0.5. The only trick is to know which one to do to your particular x value. So the idea here, if your x value, let's say, is greater than a particular amount, let's say it's greater than 20, what integer values were going to fall in this particular inequality? Because again, this is when you were discrete, and once you add the continuity correction, that is what would happen when you're going into continuous. So if you were discrete, you're only be going to look at integer values, right? So in this particular case, this would have been valid for 21, 22, 23, and so on. So you want to add or subtract 0.5 in such a way that these set of integers do not change. And in this case, if you add 0.5 and you get 20.5, I could very well write this as x is greater than 20.5, and you'd still say, yeah, the integer values this would be applicable for or valid for would still be the same. If on the other hand I subtracted 0.5 and that gave me 19.5, well, then it wouldn't be the same, because it would be valid for 20 as well, and this wasn't there in the initial case, hence you wouldn't be subtracting. So that's one idea. And you can just flip it around if it's less than. When, however, x is greater than equals to, let's say, 35. Now, which integer values is this applicable for or valid for? So it includes 35 because it's equals to as well, and 36, and so on, all the way to infinity, or whatever. If it's a binomial distribution, then obviously there'll be a upper limit, that is the number, your sample size, your sample size basically. If it's a Poisson distribution, then it would go on until an infinite value of x. But yeah, so hence you want to add or subtract 0.5 in such a way that this set of integer values remains unchanged. And in this case, if you subtract 0.5, you should get 34.5. And now if I write it like this, same notation, x is greater than equals to 34.5, and ask you which integer values this would be valid for, that would still be 35, 36, and so on. However, if I was to subtract in this case, that would be an incorrect continuity correction. Sorry, that would give me, okay, so no, sorry, I did subtract. Subtraction was the correct one. If I was to add in this case, that would give me 35.5. Now this would be incorrect. Why? Because this would be valid for 36, 37, and so on. Even it would miss out the integer 35, which is required. It was there in our initial set of integer values for which x was valid. Here it's not there, so this would be an incorrect continuity correction. So instead of having to memorize a bunch of boring rules, just try to think of the integer values that it would be valid for, and add and or subtract appropriately, you might have to try either adding and subtracting and then just looking what seems correct, and just try to ensure that the integer values it's still valid for is the same. I'll just do one quick case where I'm doing less than. Um, so let's say x is less than 20, and then here let's do x is less than equals to 20. If it's less than 20, then it's valid for stuff like 19, 18, all the way down to 0. If you add, no, if you subtract in this case 19.5, this is fine because you're subtracting 0.5, because this will still give you 19, 18, and so on. If you're going less than equals to 20, then this gives you 20, 19, and so on. So you would want to add in this case, add 0.5. You're either going to be adding or subtracting 0.5. So that's the only decision you need to make. Because if I write this is correct, because this would still give me 20, 19, 18, because if I think of integer values less than 20.5, 20 is included in them. So this is the way I like to remember and figure out my continuity correction.